Hello everyone, so here we are again. This is the second bonus video in our research skills analysis of variance course. So today mainly what I want to do is I want to show you how I would typically carry out a repeated measures ANOVA. And then briefly I'll also show you how to extend your repeated measures ANOVA into a mixed ANOVA. But before doing so, let me show you some slides first, just a couple of slides with some announcements. Right, here we are. So the first thing I wanted to show you once more, and I've also showed you this. I've also shown you this the very first video lecture, are the learning goals for this course, sometimes also called the course aims. And I just wanted to show them to you once again, such that I hope that you will realize that you already made quite some good progress in terms of this course. We have those 5 different learning goals or course aims. For instance, relating to how to formulate hypotheses, how to choose the appropriate statistical analysis if you have a certain data set or a certain research design, how to carry out those different analyses, how to look into assumptions, and how to interpret and report those analyses. So basically all of those things we've already been practicing, right, over the last couple of weeks. So that's good. And for the coming weeks, we'll just practice a bit more. And then actually at the end of the course, I'm pretty confident that you will be able to carry out all those different things. Come up with the appropriate analysis for research design, run the appropriate analysis, check those assumptions, and also report the results of your analysis. And more specifically, actually, those first 2 learning goals, they were tested already in assignment 1. And the final 3 will be tested in assignment 2, and then all 5 of those together, they will be tested in the exam. So that's a very straightforward design for this course, I think. Right, so then a couple of questions that were asked more than once over the last couple of weeks. So some of you asked me to say a bit more about the so-called floor effects or ceiling effects, because probably you found those terms in the checklists, but I didn't really talk about this too much yet. So basically floor effects and ceiling effects are things that you want to ignore in your study. And it's good to check whether once you have a data set or once you have carried out a study, it's good to check whether you have any floor effects or ceiling effects. Now, what does this actually mean? Let's start with the ceiling effect. So imagine you're doing a study and you want to test people's intelligence. So you design a nice test with which you think that you can measure people's intelligence, and you give your test to say 60 people, and they can get a score for this test. Now you carry out this test, and in the end, what you find out actually is that for all 60 of your participants, there was an extremely high score. So say if they could have gotten 100 points in total, all of them got maybe more than 97 points. So all of them got very high scores. Well, what this basically means is that there might be a so-called ceiling effect. Apparently your test wasn't very good at measuring what you wanted to measure, because basically everyone more or less had the same score. There weren't too many differences in your dependent variable. And the opposite is a floor effect. So in this case, everybody has a very, very low score on the same measure. And in both those cases, when you have a floor effect or a ceiling effect, basically means that there's not too much variance in your data. So finding certain effects that you're interested in is already very hard because of the way in which your test was designed. So if you think, for instance, of all those survey questions that we're typically looking at in those data sets that we use, for instance, if all your scores on those survey questions were around 7 on a scale of 1 to 7, then there's not a lot of room, right, to find any effect. The opposite is a floor effect. So if on those measures, on those survey questions, if people could have scored 1 till 7 and they all scored 1 in all questions, there's not much room to find an effect between different conditions, right? So this is simply something you want to check before you start carrying out your analysis. And you simply do this by looking at your descriptives. So you look at the different averages per condition or per item, per measure. And if you see that all the scores are very low, then there might be a so-called floor effect. And if you see that all your scores are very high, then there might be a so-called ceiling effect, meaning that there isn't too much room probably in your data to find anything. So that's what this means, basically. Yeah, one other more frequently asked question is related to reporting your outcomes of your analysis and how to do this in APA style and how to practice this a bit. So here I think there are 3 different sources that would be good to use if you want to practice this. The first source that you could use is, of course, the book by Andy Field. So in many of his chapters, there's a section called reporting, and then something more like reporting the results of your regression analysis or reporting your analysis of variance. And here he also reports the results in APA style. So this is the first source that you can use. Look at your book and see how Andy Field reports things, and then see if this corresponds to how you report things. Of course, the second source that you can use is the APA guidelines themselves. So they have a manual, as you hopefully know. The APA has a manual with all the rules, APA style, how to report things, what to do, what not to do. For instance, the APA manual tells you if you're reporting a table with information, there can only be horizontal lines in it and no vertical lines. So if you report the table yourself, then based on this manual, you will know, okay, I can only include horizontal lines in my table and no vertical lines. And one other thing you can do, obviously, and I think one thing that's very helpful, how most people actually learn it, is to look at existing research papers. So papers reporting data always have a results section where they report things, and often in APA style. So the more of those research papers you read, the more experience you get in seeing how people report things. And then you can also take over those habits yourself. So I think those are 3 different sources that you can use when you want to practice how to report your outcomes. One more thing I wanted to say before we're going to look into the data set is this assumption of normality. So last week in the first bonus video, we looked at regression analysis. And as you hopefully know by now, in regression analysis, there is the assumption of normality. There are 7 assumptions, and one of them is the assumption of normality. And here you test for the normality of your residuals, so the normality of your errors, right? That's what we did last week by looking at those graphs and those plots. That's one way of checking normality. So in regression, the most important thing here is you check the normality of your residuals. So today we're going to look at ANOVAs, and there's also the assumption of normality, but just to make sure you don't get confused, the normality here in ANOVAs does not refer to the residuals, but it actually refers to the data itself, meaning that actually for within subject variables in your ANOVA, you're going to test for the normality of the difference between your conditions. And I'll quickly show you in SPSS how to do this. If you have between subject variables in your ANOVA, what you actually do is you check the normality of your individual conditions themselves. So not the difference between conditions, but the individual conditions themselves. So the raw data in your individual conditions. So basically, those are 3 different ways in which this assumption of normality is being instantiated in different ways. So in regression, it is the residuals. For within subject variables in your ANOVA, it's the normality of the difference between your conditions. And for between subject variables in your ANOVA, it's actually the normality of the raw data in your individual conditions. So I hope this slide will avoid some confusion with this very specific assumption of normality in the different tests. All right, that's what I wanted to show you before going to the data. So let's now go and move towards the data set. And I'm going to use the data set for the practice assignment for week 5. See if this is working. Ooh, looks like my SPSS is crashing here. Okay, that never happened before. Let me relaunch SPSS. Okay, now close SPSS. I'm going to reopen it on my own computer before sharing it with you again. Yeah, so those are the hassles of online teaching. Okay, I'm opening SPSS myself again now. So as you might realize also on your own computer, probably SPSS is not a very quick program. Often takes some time for it to open it. Still working on it. Well, so maybe now SPSS is opening. Let me, before we go to the data set, remind you of the exam. So for the exam, university is working very hard, right, to make sure that you won't get any delays in your study program. And for this course, this means that the exam has now finally been scheduled. I hope you've seen this. So it has been scheduled for June 4th. But the exact time slot for the exam hasn't been scheduled yet, as far as I know. So in the coming weeks, I will also find out whether this is something I will do myself, just picking a couple of hours on this June 4th, or whether the university will schedule it for us. Of course, once I know this, I'll let you know. So the exam probably, it's going to be a couple of hours on June 4th, in which you will just get the exam via Canvas, and then those learning goals will be tested. And then you just hand in the exam again on this same day to me. And that's just how we're going to do it. But as I said, more information will follow. All right, let me try and share SPSS again with you. Yeah, and now I hope you will also see SPSS. Right, it looks like this is working. So this is the data set for week 5, for the practice assignment for week 5. And as always, there's a lot of information in there again. For showing you how I typically carry out a repeated measures analysis, we're just going to use this very small part of this data set. So here, in the bottom of this file, you will actually find 6 different rows. So those correspond to columns actually in your data view. So here in the variable view, they are rows. And here actually we have the input for our repeated measures analysis. And the interesting thing about the repeated measures analysis compared to different types of analysis, different types of ANOVAs, is that actually your independent variables are not yet nicely presented in one line of this file here. So previously for regression analysis and for one-way ANOVAs, there were just very simple individual lines here giving you one independent variable, giving you one dependent variable. Actually, what you see here for as the basis for repeated measures analysis is not yet those individual factors, independent variables, and not yet your individual dependent variable. Because in repeated measures analysis, things work a bit differently. You actually have to define your independent variables yourself in the repeated measures menu. And here, actually, we're going to use those 6 lines to do so. And already by looking at the name of those different measures, you can already more or less tell what kind of independent variables there have been in this study. So here you see 3 different types of websites: news websites, health websites, and commercial websites. And you actually see them twice, right? You see them once in the context of non-personalized websites, and you see them once in the context of personalized websites. So once you start working on the practice assignment for week 5, you will actually read that in this study, a group of people was asked to give their attitude, so that's what the AD stands for, about 6 different types of websites: news websites, health websites, and commercial websites, both in the case of non-personalized information and in the case of personalized information on those websites. So there are basically 6 different conditions, and those are the 6 different conditions you find here in a 2x3 design. So there was a first 2-level independent variable, non-personalized or personalized, and there was a second 3-level independent variable, news, health, or commercial websites. So in this 2x3 design, 2x3 makes 6, right? There were the 6 different conditions. And in the repeated measures analysis, you're going to define those 2 different independent variables yourself. Now, before starting to go into this dialog window for the repeated measures, the first thing you should do, of course, is check your assumptions. And we've just seen that for repeated measures analysis, the assumption of normality is also important. And not just the normality of your residuals or the normality of your raw data, but actually in this case, because those are two within subject variables, you should check the normality of the difference between your conditions. So here we have 6 conditions, right? And you can look at the difference of each pair of conditions, right? So condition 1 minus condition 2, condition 1 minus condition 3, etc., etc. And in this case, actually, if you have 6 conditions, there are 15 different pairs possible to check the difference between conditions. I'll show you how to do this for one. And if you have 6 conditions yourself, you should do this 15 times. So the nice thing about repeated measures Anova is that we only have 2 assumptions. But the nasty thing is that if you have many conditions, there are many differences between conditions. So this normality, checking this normality assumption takes some time. Right, so how do you do this? Check the assumption of normality for a within subject variable. You go again to to transform and compute variable, which we also used last week. There we are. And what you want to have here is the difference between different conditions, right? So let's create a new variable to do so. Let's call D1 for difference 1. And what you simply do is you take the first condition, tap the minus sign, take the second condition, and what you will get now as a new variable is actually the difference between those two, right? Very easy. Now, actually, I will do this for one different score, but as I said, if you have 6 different target variables, you can do this for 15 different combinations. So you should do this for all 15 combinations of different. So you create target variable D1, and then you do it again for D2, for D3, and each possible difference between 2 conditions should be in there. So you get 15 in total. So I'll just do it for one. I just quickly press OK here. So now we get a new variable actually in our condition, in our data set. And you will see it here, line 37 in this case, D1. So this is going to be the difference between those first two conditions, right? Now you want to check the normality of this difference. So you're checking the normality of the difference between conditions. And last week we looked at normality by simply looking at some plots, right? That's one option. Another option that some of you will be familiar with is to look at the skew and the kurtosis of your variable. That's another option. You can also do that if you prefer that. But keep in mind, if you do this for within subject variables in an ANOVA, you should look at the skew and the kurtosis of the difference between conditions, right? No, you shouldn't look at the raw data in this case. What I'll show you today is how to look at the normality using this Kolmogorov-Smirnov test. This is something you do by going to Analyze, Descriptive Statistics, and then Explore. So here you enter your new difference variables. In this case, there's just one, but if you do this for your 6 conditions, you can enter 15 different difference variables here. And then actually, if you want to check the normality of these difference variables, then here under plots, you tick the box normality plots with tests. And this will actually test for the normality of your difference between conditions here. If you then press continue and press OK, then in your output, you will get this normality test. All right, so that's checking the normality of the difference between conditions for within subject variables in an ANOVA. So that's something you do before you start carrying out your repeated measures ANOVA. So let's look at that now. So if you want to carry out your repeated measures ANOVA, you go to Analyze General Linear Model, and then you select Repeated Measures. And now this is actually where it starts to become different compared to regression and also compared to more simple ANOVAs. Because now in this case, you have to start defining your independent variables yourself. Well, remember we had 6 conditions in a 2x3 design, meaning that there are basically 2 independent variables. The first one we can call personalization. Right, there were personalized websites and non-personalized websites. So this has 2 levels, right? Personalized and non-personalized. And our other independent variable here, you could call a type of website, right? And we have seen that there were 3 different types of websites in our study. So here you have 2 by 3, the 6 conditions covered by 2 independent variables. Here I call this type of website. You will see that in the output of the practice assignment, in the correct answers, it will be called context. That's, the reason for this is that you basically can make up the name of your independent variables yourself here. Right. So now for now, let's just call it personalization and type of website. And if you press define, then you'll get into this kind of dialog window that you might be more familiar with already. And what you see here is now we have those two within subject independent variables here, personalization and type of website, but we still need to specify to SPSS what the actual conditions are in this case, what the individual conditions are. And here you see that SPSS wants you to organize things according to different levels. So here, personalization has 2 levels. And your first condition here needs to have level 1 of personalization, second level as well, the third level as well, and then you should have the second level there. So here we should put the same value of personalization in the first 3 options, and then the other option of personalization in the bottom 3 options. And then for type of website, there are 3 options, right? 1, 2, 3, 1, 2, 3. So in any case, you always have to make sure that those numbers here correspond to the right conditions. So if we now enter our 6 conditions into this box, so what you see here first is the different types of websites, right? So we have news, health, and commercial websites. And again, we have news, health, and commercial websites. And those correspond to type of website, right? The type of website should be 1, 2, 3, 1, 2, 3. This is the case, right? So 1 here is now news, 2 is health, commercial is 3. And again, news is 1, health is 2, commercial is 3. So for type of websites, we're good. For personalization, it says 1, 1, 1, 2, 2, 2. And then here, in this case, non-personalized corresponds to 1, personalized corresponds to 2. So in this case, we're doing this in the right way. You have to make sure always that if the number here is the same in different lines, then also the label should be the same. So you could also have done this the other way around, such that this would be personalized, 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 non-personalized, non-personalized, non-personalized. As long as whenever there's the same number here, there should be the same label in your condition. So in this case, we did this correctly. So now we actually have provided the basic information for SPSS to carry out our repeated measures Anova. But of course, as you see here, there are a couple of different buttons that you can select from. Let's start at the bottom now for the bottom button. In this options button, you can select a couple of different interesting and relevant types of information. For instance, the descriptive statistics, that's something you should always report, right? So let's tick this button here. And also you can get those effect sizes again for free. You don't have to calculate them yourselves. So you can just select them here. And for now, let's just only select those 2 options for in the output. That's nice. We get the descriptives and we get the estimates of the effect size. Is there something more we should do? Let's ignore this for now. One thing I should tell you, in ANOVAs in general, as you hopefully know by now, you will get main effects and you will also get interaction effects. And you'll find out in the basic output whether you have any significant main effects and whether you have any significant interaction effects. However, finding a significant main effect or finding a significant interaction effect will tell you that different groups significantly differ from each other. But if you have more than 2 levels in your independent variable, as we have here, right? Because we have 3 levels for a type of website, news, health, and commercial. If you have more than 2 levels and you find a significant main effect, you don't know yet which of those different groups actually differ significantly from each other. So it could be that all those groups significantly differ from one another. So all different pairs of combinations could be significantly different. Or it could be that there are just 2 out of 3 that are significantly different from each other. Well, to find this out, to find out more about this, you can do 2 different things in general. Either you do planned contrasts. This is typically what you do when you have specific predictions already for which specific comparisons you want to make. If you just want to compare all different groups to each other, you typically do post hoc tests, right? Because post hoc tests just compare all possible combinations to each other. Well, those planned contrasts to start with, you can specify those by clicking on contrasts. The default version here is to do a simple contrast. So you select simple and change it for both of your independent variables, you'll get the simple contrast. And in those cases, you always have to select a reference category. So if you have specific predictions and you want to compare your conditions to the last category, to the last level of your independent variable, and in this case, the last condition here is the condition here that has the lowest value. So for personalization, the last condition will be personalized information. For type of website, the last category, the last level will be commercial. So for personalization, actually here, this contrast is not super relevant, right? Because it only has 2 levels. So if you find a significant main effect, you already know that those 2 levels differ from each other. But for type of website, now imagine you're theoretically only interested in comparing news to commercial and to comparing health to commercial. Then you would select last here as your reference category, because then those 2 levels will be only compared to the last level here, so to commercial. If you want to compare everything to everything, you shouldn't do a planned contrast, but you should do those post hoc analysis. All right, so if we press continue, we're going to get the output here. If you want to do post hoc tests instead, strangely enough, for within subject variables in your repeated measures, you shouldn't select post hoc, but you should select this button here that looks at the means. And then what you can actually do is for your independent variables, you can move them into this box here. Ask SPSS to compare main effects. Most people here select the Bonferroni correction option to adjust your confidence intervals. And if you then have selected compare main effects and click continue, then you will get your post hoc output. So then all different conditions are compared to one another. So you get all the different comparisons, and SPSS will tell you whether any of those comparisons will be significantly, whether any 2 conditions in any comparison will be significantly different from each other. All right. So basic takeaway message here, specify your different conditions here in this box, such that they correspond to the numbers. A priori, before you start running the test, decide whether you want to do planned contrasts or post hoc tests. I selected both of them now for illustration purposes, but typically you yourself, based on your hypothesis, you know already whether you want to do planned contrast on the one hand or post hoc test on the other. And once you've done all this, then you can actually press OK, and then you will get your output. So maybe we should do that now before going into Mixed Anovas. So I'll press OK here, and then SPSS will actually start running all this analysis for you. This takes some time. Right, so now all the analysis have been carried out. And I learned last week that I now have to share the right screen again with you. So I'm going to stop share the dataset, and I'm now going to share the output with you. There we go. So here's your output, and there are basically 2 types of output here in your output screen. First, remember that we did this test for normality, right? Using this Kolmogorov-Smirnov test. So this is now under Explorer, so let's open it for now. And here also in this test, you get some descriptives, but they are not super relevant now because they're actually the descriptives of the difference between your different conditions. Whereas in your report, you typically report the difference across for each individual condition and not for the difference across conditions. So for now, let's just ignore this. And here you actually find your test of normality. So the Kolmogorov-Smirnov test of normality has been carried out. You also get the Shapiro-Wilk statistics, but more typically people look at the Kolmogorov test. And actually what you find here is whether your test of normality was significant or not. And here actually for the difference between those 2 conditions, it was significant. So there's a significant test of normality indicating that SPSS tells you that probably your this assumption of normality for the difference between those two conditions wasn't met. So if this test is significant, it means your assumption is not being met. Well, then there are different things you can do. Let's see what we actually got here. Right, so I see that I didn't ask for a histogram this case, but we still got a normal QQ plot. This is very similar to this PP plot that we looked at last week. And here actually, in the case of normality of your data, those individual points here should be exactly on this diagonal line. And you actually see that this is more or less the case, even though you find that your assumption is not being met. Still, the individual data points more or less are on the diagonal line with one outlier here probably. Well, if this is the case, typically people say, okay, my test of normality wasn't being met for the difference between those two conditions, but when I looked at the normal QQ plot, it didn't look too bad actually. So in the end, probably most people won't actually do something about this. So this is how you test this. You first check for all your differences across your conditions. So in your case, in practice assignment for week 5, those will be actually 15 different tests here. You test whether there are some significant or not. If there is one significant or if there are more significant, look at different plots, like this QQ plot here, or select the histogram option when you're doing the Kolmogorov test. And you also, like last week, you get this nice histogram with to check whether there's a normal distribution or not. And if it looks okay, most researchers will actually say, okay, it still looks okay. We won't do too much about it. There are things that you can do about this if your assumptions are not being met. For instance, if your assumption of normality isn't being met. And those are actually discussed in chapter 6 of your book. So if you want to know what to do about assumptions that are not being met, please have a look at chapter 6 of your book, and there you have the different options. So one is, for instance, called trimming your data. Another option is transforming your data. Those are things you can do if you have serious problems with meeting different assumptions. All right, so this is the output of the normality test here for the difference between conditions. In this case, just exemplified with just one difference, but there will be more typically. And then also the other thing that we asked SPSS to give us, right, is the output of the repeated measures analysis. And that's what we're finding here. Right, so here, first you get a nice overview of what you actually did, what you entered into your dialog window. So here you can double check whether you did things correctly. So there are 3 types of websites, right? 1, 2, 3. And this corresponds to news, health, and commercial. And here also 1, 2, 3, news, health, commercial. So we did this correctly. And there are 2 levels of personalization, 1 and 2. 1 here stands for non-personalized websites, and 2 stands for personalized websites. So that's also correctly done here. Then you nicely get your descriptive statistics, which you can nicely report in your report. So you get your mean value for each condition and your standard deviation. And here you see that there were 262 participants in your data set. Here we have multivariate tests. Mostly people just ignore those because people tend to prefer the within subjects output test. So let's just ignore them for now. Make sure that you find the right table. So because this table looks very much like the within subjects table, but for now, just ignore the multivariate tests. Here we actually get our test of sphericity, right? Remember that I said that for repeated measures Anova, there are actually 2 different assumptions you have to check. One is normality, so that we checked with this Kolmogorov test, and the other is actually sphericity. And the sphericity assumption is checked by default by SPSS if you run repeated measures Anova, so that's nice. And you see the output here. So for each main effect and also for the interaction effect, this sphericity needs to be tested. However, as I said in the video lecture for week 3, I think, if your within subjects variable only has 2 levels, then you don't have to check for sphericity. This is only relevant when your independent variable, your within subject independent variable, has 3 levels or more. So for personalization, which has 2 levels here, we actually don't even get an output because it's not relevant for independent variables with only 2 levels. So this you can just ignore. Now for type of website, which has 3 levels, you have to check it. And then you see that it's not significant. So this is good. So for this type of website, independent variable, sericity is not being violated. But as you can see, for the interaction effect, actually it is. So here you find a significant effect here for the test of sericity, testing for the sericity of your interaction. So if this value, the significance value, is lower than 0.05, it means actually that your assumption is not being met. And the nice thing about Mauchly's test of sericity is that if it's being violated, there's a very simple thing that you can do. Namely, you can report not the general output, but you report the corrected output. And there are basically 2 options that people use, either the greenhouse geyser option or the Heinfeld option. Which of those 2 you should use depends on the epsilon value of the greenhouse geyser outcome for the interaction effect in this case, because that's the only one that was significant. Now here you find a greenhouse geyser value, an epsilon value. If this value is larger than 0.75, then you should actually not report the greenhouse geyser correction, but the Heinfeld correction. If this value is lower than 0.75, you report the greenhouse geyser correction. Right, so if you have a significant violation here, you check whether the greenhouse geyser value for that line of the table is smaller or larger than 0.75. If it's larger, and that's the case here, right, because 0.909 is larger than 0.75, later on you will actually report the Heinfeld correction for that line of your table. So in this case, for the interaction effect. Let's see what this looks like actually. So here's the main output, your test of within subjects effects. And this is the main outcome. So here, this is what you're actually interested in the end. So actually what we find here is for personalization, our first independent variable, we don't find a significant effect. So there's no significant effect of personalization in your data. Meaning that people did not have a different attitude towards personalized websites versus non-personalized websites. Then we do find a significant main effect of type of website, right? Very clearly significant. So this shows that there are, between the different types of websites, there are significant differences. However, on the basis of this output, we don't know yet which of the exact groups, which of the exact types of websites differ from one another. And that's why we already selected those either planned contrasts or post-hoc checks, right? We'll get there later. But now first you would report there's a main effect, a significant main effect of type of website, or in the practice assignment it was called context, meaning that the different types of websites overall significantly differed from each other, but we don't know yet which different groups actually differed, which exact type of websites actually exactly differed from each other. We'll find out later. And of course, you also then can report the effect size here, right? A partial eta square of 0.22. Right, so here, the interaction effect is actually also significant, as we see here. And remember that for the interaction effect, the sericity violation was violated. So therefore, from those 4 different options, we don't report the sericity assumed line as we would do for the 2 main effects here, but here actually we report the Heinfeld line. So this basically means, in this case, that actually only your degree of freedoms that you report are slightly different from what you would normally do. But in other cases, actually, for instance, also your F value could differ, or your significance could differ as a function of which of those 4 lines you take. So because the sericity assumption was violated here, and this epsilon value for the greenhouse geyser was larger than 0.75, we here report this Heinfeld line. So this is the line you then report. Of course, you also don't know yet what actually your interaction effect means, right? Well, what it could mean is that this main effect of type of website is actually there, but only for one form of personalization and not for the other. So it could be that your type of website main effect is there overall, but if you zoom in onto your type of website effect separately for your personalized conditions versus your non-personalized conditions, it could be that their main effect is there in one group and not in the other. So that's what your interaction effect could mean. This is typically also something you would still need to find out after you found out that there is this significant interaction effect. All right. If you're interested in planned contrast, then here you have the output. So actually what you find here is more information about your significant main effect of type of website. And what this planned contrast output tells you is that if you compare level 1 to level 3 of your types of websites, there's no significant effect. But if you compare your level 2 to level 3, there is a significant difference. So here it says group 1 doesn't differ from group 3. Group 2, however, does differ from group 3. Remember that we selected this level 3. So in this case, those are commercial websites as our reference category. That's why the other two conditions are compared to the reference category, to the commercial websites here. So here, if you want to know again what level 1, 2, and 3 stand for, you go back to your descriptive information here. There says type of website 1, those were news websites. Type of website 2, those were health websites. Type of website 3, those were commercial websites here, right? So 1 was news. So actually this means that the news websites were not significantly different from your commercial websites, but your health websites, they were significantly different from your commercial websites. That's then something you can report based on this table here. Well, there's a between subject effects we can ignore because there were no between subject variables, right? We do a repeated measures Anova and not a mixed Anova. And here you get the post hoc output. So here, for personalization, we already knew that there was no significant main effect, right? Makes sense because the mean values are actually very close together. And if you would compare level 1 to level 2, so personalized websites to non-personalized websites, indeed, there's no significant difference between the two. However, for type of website now, we're not just comparing, as in the planned contrast, the reference category to the other conditions, but we're comparing everything to everything. So here, for instance, news is compared to health. That's a significant difference. News is also compared to commercial. That's not a significant difference. And here again, health is compared to news. That's the same as before, right? Because it's just 1 compared to 2 versus 2 compared to 1. Those are the two same conditions. Again, significant effect. Level 2 and 3 differ significantly, and those we already saw before above because 3 was compared to 2 already and also to 1. So here, main takeaway point, if you do those post hoc tests or those pairwise comparisons, all conditions are compared to one another and you will know exactly which conditions differ from each other. All right, so for the main effects, we're good now, right? So we know that there's one main effect of a type of website and we know exactly which of the conditions differ from each other. But we don't know yet exactly what this interaction effect that we have, what that actually means, right? We know that there is an interaction effect, but we don't know exactly what it means yet. One way of interpreting your interaction effect that is not very straightforward is by looking at this within subjects contrast. So if you look at the book chapter about repeated measures, there's really a step-by-step explanation of how you should interpret interaction effects as a function on the basis of this table. But this is not very straightforward. It takes you quite some brain power to completely understand this. So what I'm going to do now is I'll show you one other way of doing this. So I'll show you how you can also follow up your interaction effect to find out what it actually means. And to do so, let me go back to the data set. So I'll share the data set again with you. There it is. Share. All right, still loading. Yeah, there we go. So here we're back in the data set, just to be sure that you also see this dialog window. So remember, we have a significant interaction effect of those two within subject variables. And now we want to know what this actually means. So what I then typically do is I run another repeated measures analysis. And now actually I will remove one of the within subject factors. So I'm going to remove personalization here. And this just leaves us with type of website. And what you see here now is no longer that there are 6 options, but there are just 3 options left, right? So now we only, in this case, have our non-personalized websites remaining. So what I typically do is I run the repeated measures analysis again, but now just for, in this case, non-personalized websites. And I do that once. And then actually I do this again. Same thing, but in this case, not for the non-personalized websites, but for the personalized websites. So now we only have those 3 personalized websites here, right? Press OK again. So what I've basically done now is I've been testing for a main effect of type of websites separately in the personalized conditions and separately in the non-personalized conditions. And what your interaction effect could mean is that in one of those 2 analyses, there's still your main effect of type of website, and in the other analysis, this main effect is gone. And this would then explain your interaction effect. Okay, so let's move back to the output then, because it should now be in the output. There we go. So let's close some of the output now. So we've looked at the normality first, right? Now we did the first overall repeated measures analysis. And now here we have our follow-up analysis for non-personalized websites only. If you then go to your test of within subject effects, you see actually that there's only one main effect left, right? Because this personalization we got rid of by separating the 2 analyses. So here for the first analysis, we actually still find a significant main effect of type of website. But you also see that it's relatively small, right? The F value is relatively small, and also the effect size is relatively small, right? Okay, so keep this in mind for the first test, in which we only looked at non-personalized websites. There was a relatively small, significant main effect of type of website. Then let's move to the personalized websites now. So here we have the 3 types of personalized websites. And here, if you look at the main effect of type of website, you see that it's very significant. There's a very high F value here, and the effect size is much larger than what we saw before, right? So now in this case, actually what your interaction effect means is not that there is a significant main effect only in one case and not in the other, but actually that the main effect of type of website is just much larger in one condition, in the case of personalized websites, compared to the non-personalized websites. So this now explains your interaction effect. So in your report, you then say there was a significant main effect. Sorry, there was a significant interaction effect between personalization and type of website. When we followed up this interaction effect, we found that the significant main effect of type of website was substantially larger for personalized websites than for non-personalized websites. Although in both cases and overall, there was a significant main effect. All right, so that explains your interaction effect. What's very nice in the case of interaction effects is when you also add a nice plot, because if you add a plot of your data, you can also visually nicely see what your interaction effect looks like. And you also practice with this in the practice assignment. And then in the outcomes of the practice assignments, also you'll find this plot and what it should look like. All right, so that was for now repeated measures ANOVA. Quite some information, right? But I hope you find this useful when you're carrying out those kinds of analysis yourself. And maybe very briefly again about mixed ANOVAs. So let's then get back to the, just to be sure, let's share my screen, the main data set again with you. So here we are. Basically, a mixed ANOVA is not too much different of compared to repeated measures ANOVA. It's just that it's called a mixed ANOVA because you don't just have within subject variables, but you also have one or more between subject variables. So if you're doing a mixed ANOVA, you first again go to your repeated measures box. Let's remove this and specify it again. So let's say we're just going to have the same within subject variables again. So let's have personalization, 2 levels, and type of website, 3 levels again. Then we can define those again, right? So again, for the within subject variables, nothing has changed. Although something has changed here, and this is a little weird. All right, so, oh, right, oh, they're still here, so I was confused. Yeah, see, there they are. So if you add those again, as we did before, this is should be matching, the numbers should be matching the vectors again, right? Let's assume this is correct now, which it is. But now in the case of a mixed ANOVA, actually we're also going to have a between subject variable. And often a between subjects factor is something like gender. So you want to compare male to female participants, for instance. So let's do that here. Basically, by entering a between subjects factor here, it means that you're turning your repeated measures ANOVA into a mixed ANOVA. And in your output, there will still be your the output that you had before, except that now also there will be information about this between subjects variable. So will there be a significant main effect of gender in your output, in your analysis, yes or no? If it's there, it means that in this case, your male participants behave differently compared to your female participants. And also what you will get now is that there might be interaction effects of your between subjects variable with your within subjects variables. And that will now also be in your output. If you press OK here again, you'll get your new output for the mixed ANOVA. And it will, the way of interpreting this is very similar to your repeated measures output. It's just that you get some more information about this between subjects variable now. So in this test of between subjects effects, you will now find whether you have a significant main effect of gender or not. And you'll find out in the within subjects factors whether there are now some additional significant interaction effects or not. And if you find significant interaction effects, you can follow them up again in the way that I showed you before for the within subjects variables. All right, that's what I wanted to show you here for the mixed ANOVA. If you press OK here yourself, you get all the output and you can scroll to all the output here. One last thing that I think is important to mention is that since we have an additional independent variable here in this mixed ANOVA now, we of course have to check some additional assumptions again, because remember, for instance, this assumption of normality for between subject factors in your ANOVA has to be checked differently compared to the assumption of normality for your within subject variables, right? One other thing is that for between subject variables in your ANOVAs, you don't check the sphericity assumption, like we just did for the within subject variables, but you check the Levene's test. Now, actually, both those things you can check by going to Analyze again, and then go to Descriptive Statistics, and once more go to Explore. Remove this difference score because we're now only going to look at between subjects variables here. Right, and in this case, you do this again for all your conditions. So remember that for between subject variables in your ANOVA, for each separate condition, so for each separate level, you're testing the normality, right? So that means here that you take your 6 levels in this case, put them in a dependent list, and in this factor list, you put your between subject variables. In this case, this was gender, right? So you put it there. Now, if you then go to plots, you can again ask for normality plots with tests. So then you get this Kolmogorov-Smirnov normality test again. And in the same box, you can actually also ask for the Levene's test to test for the homogeneity of variance, because that's what that's the assumption that you test with your Levene's test. So here it's best to do this on the untransformed data, so on your raw data. And then, all right, so see here, before I didn't select this histogram option, right? So it's good to check this as well. So you also get this nice histogram that you can use to check your normality. So if you then press continue here, and press OK, then in your output, you'll actually get your normality tests and your Levene's tests. So let's wait until SPSS has managed to run all this. SPSS is a little slow today. Maybe, yeah. Maybe because I'm recording this over the weekend. Maybe SPSS is also recovering a bit during the weekends. Come on, SPSS, you can do it. Still running. Okay, I just have to practice my patience here a bit, I guess. Oh, there we go. Okay. So I'm now seeing all this output here. So I'll share my screen again with you. I'll share the output screen again. All right, so here you see the output. And actually, in this case, there's a lot of output, as you can see here in the left-hand window. So let's just start at the top here. Here you just get a summary of what SPSS actually did for you. One important thing here to notice just is that it's now split the output looking at male and female participants separately. You get a lot of descriptives here. So remember, this is not the descriptives anymore of the differences between conditions, but actually the descriptives of your different conditions themselves. So this is actually quite useful if you want to report different things like the averages or the confidence interval, or if you want to look at the skewness or the kurtosis. We get this for all the different conditions. And then here you find your tests of normality now for each condition split out for the different between subject levels, so male and female. So here again, what you do is you test whether you check whether any of those is significant or not. If it is significant, which is the case here for this one here, 0.01, almost for this one, but not exactly, and for this one, 0.04, then for those you actually check then also the plots, so this QQ plot and also the histogram, to see how bad things are. And if you think they are really bad, then there are things you can do, like trimming your data, transforming your data, in the way it's mentioned in chapter 6 of your book. Right, so this is the normality test, and then right below this, you find the Levene statistic, testing for the assumption of homogeneity of variance. And here also for each, in this case for each condition, you find the outcome of your Levene's test. And again, it's important to see whether it's significant or not. One other important thing here is that there are different options, right? People typically use the line that says based on the median. This is most often used by most researchers. So you check the p-value, you check the significance value of this line in your output for each of your conditions. So here it's clearly not significant, right, for this condition. For this condition, it's also not. But for one condition in this case, your Levene's test is actually significant. So this means that for this condition, this homogeneity of variance assumption is not being met. And again, there are things you can do about this, like trimming your data or transforming your data. And again, you can check chapter 6 if you want to know how exactly to do this. And here, some people are more strict than others. Some researchers say if one of those 6 conditions, if you find a significant Levene's test, they say, okay, then we'll transform the data. Others say it's just 1 out of 6. We'll just report the data in the way that they are, report the outcome of the analysis in the way that they are. And we'll just report this, and we'll interpret the data, interpret the results with a bit more caution than usual. On the other hand, there are also people like Andy Field who say you should always actually trim your data and always transform your data. That's the other extreme. So in this case, I would say just look at the outcome of your Levene's test, report the outcome, and then if it's 1 out of 6 conditions here, I would typically say myself, oh, it's just 1 out of 6. We're just going to interpret the results in the way they originally were, and interpret them just with a bit more caution than normal, especially in the case of this very one condition here for which the Levene's test was significant. All right, so I think that sort of concludes this relatively long bonus video. So we looked at repeated measures ANOVAs, right? Looking at the different, only 2 assumptions that there are. So it's kind of nice that there are only 2 for a change. Then we looked at how you should interpret the output, contrast versus post-hoc, options for really zooming into different assumptions, into different conditions of your independent variables. Then we looked at how you could follow up your interaction effects. And finally, we looked at mixed ANOVAs, what the assumptions are there, how you should get the output for those assumptions, and how to interpret those. So I think this should nicely help in carrying out those types of analysis yourself and knowing how to interpret the data. I hope it also will be useful for the practice assignment for week 5. So I guess that more or less concludes this bonus video. So I hope you'll have a nice week again this week. I hope you're still doing fine. And as always, if you have any question, just send me an email. And also, if you want to ask a question and get an email right away, then please join the Q&A session again. All right, then thanks for watching and see you next time.